All right, hey everybody, this is 12.1 Trig Ratios. So this unit is about trigonometry. And trigonometry comes from the word triangle and metry meaning measure. So we are going to talk about how to measure or find the measures of a triangle. Triangles have angles, they also have sides, and we're going to learn how to find all that information using trigonometry. Okay, but before we get into that, let's talk about what we're covering today is trig ratios. So what is a trig ratio or a trigonometric ratio? It is just the ratio of two sides of a right triangle. So looking at a triangle, we have three sides. If we wanted to make, I don't know, if we just come up with some numbers, maybe like 3, 4, and 5, that's kind of a special triangle. If we wanted to, we could come up with some ratios. So we could combine these two together or bring them together and we could make a ratio. A ratio is just a way to compare those sides. Okay, so there's one. We could also use those two. We could do 4 over 5, or we could also do 3 over 4. Okay, so these are all ratios. We're comparing those sides. All right, so just that's all we're really trying to figure out today is those ratios. All right, but okay, these sides we need in order to ask what sides we need to like compare or what ratio we need to come up with, we need to talk about this vocab. So reference angles, hypotenuse, opposite side, and adjacent side. Okay, you're welcome to pause and write this information down, and we will talk about it while looking at a triangle. So the first thing is the reference angle. So the reference angle is the angle that we are given or we're trying to find. Okay, we use a special variable when we use angles. Oftentimes, most of the time, we'll use what's called theta. It's like a zero with the line going across. Okay, so that is called theta. It's a Greek word. It's what we usually use for angles. It's kind of like when we use x, usually you use x's and y's when we use like equations that we're trying to solve. Here we're just using theta for angles. Okay, and that's not always the case, but most of the time it is. We'll use theta. All right, so that is our reference angle, and sometimes you'll be able to choose where you want your reference angle to be, but it always has to be either that angle or that angle, okay? The reference angle can never be the right angle, okay? So let's choose there. Again, it will make more sense when we get into some problems. All right, next we're going to talk about is the hypotenuse. So the hypotenuse is the longest side. It's always across from the right angle. So here is our hypotenuse. I'll abbreviate that as HYP, but again, it's always across from that 90 degrees. So we can always find that really easy, straight up. Probably should do that the first thing. Okay, we're going to label these sides as we go along. Okay, next we have is the opposite side. So the opposite side is the side that's opposite or across from that reference angle. Okay, so here's our reference angle. If we go across or opposite of it, that is our opposite side. Okay. And then the last thing is the adjacent side. So the adjacent side is the side that's adjacent or next to that reference angle. And it's never the hypotenuse. So here, this would be what's next to. That's our adjacent. Okay. So those are like the three things you need to be able to find is the hypotenuse, opposite, and adjacent, given a reference angle. Okay, so let's do that. We're going to do this one together and maybe pause and try the other two. So they want us to, given the reference angle, label the three sides of the triangle as hypotenuse, opposite, and adjacent. Okay, so here is our reference angle. This would be our hypotenuse. I'll just call it H. And then we have our opposite. And then we have our adjacent. So one way this kind of helps me is I start with my reference angle, right? Next we have is our H. And again, that's always across from our 90. And then we have OA, so HOA. Some of you might have heard of HOAs, Homeowners Association. Some of you guys may have one of those in where you live, or maybe not, but that's how I kind of remember that, HOA. So start with H, and then you just go around, okay? All right, so why don't you pause and do these other two. Okay, so here we have our H. Again, it's across from that 90. And then we have our opposite, and then we have our adjacent. So same thing here, we have H, O, A. All right, so it's going to be important also, again, to be able to label those, because we're going to do that for every problem this unit. All right, so let's talk more about, we kind of talked about this a little bit, like having a reference angle, and there's two places you could have a reference angle. So we just want to talk about how it's going to make a difference. Is there going to make a difference? Does it matter which angle we use for our reference angle? Okay, so if we used A as our reference angle, what would be our hypotenuse? Well, it would be that little c here, and then here would be our opposite. So opposite would be A, and then B would be our adjacent. But what if we were to use angle B as our reference angle? Well, we would still have H for our hypotenuse, and then, but now we would get opposite would be B. So we have H here, opposite would be B, and A would be adjacent. Okay, so no matter what, H is going to be H. But depending on your reference angle, your O and A, your opposite and adjacent, can change. So make sure you're paying attention to say, well, what is our reference angle? And then from there we can label our sides. Okay? All right, so this is the big picture of trigonometry, is that there's a relationship between the reference angle and the ratios of two sides of the triangle. Okay? So if you were to know, like, I don't know, let's see if we can come up with an example. If you knew that the height was here and the hypotenuse, I mean the opposite and the hypotenuse, we should be able to figure out what that angle is, right? Or if we were given like the hypotenuse and we knew the angle, then we should be able to figure out how high this would be. Okay, so there's just this relationship between those angles and their sides. And these are those relationships. These are what are called trig functions, trigonometric functions. They relate the angle to the ratio of two sides. So the first one, this function, again, this isn't sine times theta, this is a function, okay? So sine of theta is always opposite over hypotenuse, okay? If you know what the opposite and the hypotenuse is, you could figure out what the angle is. Or if you were given the angle and one of those two sides, you could find the other side, okay? So that's for sine. We use opposite over hypotenuse. Cosine is adjacent over hypotenuse. Okay, so same sort of thing. And then tangent uses opposite over adjacent. Okay, so these are all the combinations that you could come up with the three sides. And we have these three functions that relates those to the angles. Okay, the way that and you will probably need to have this memorized. So memorize. Okay, but there's kind of a nice way to remember this is what's called, well, I guess you could, like an acronym, is SO, CA, TOA. Okay, so that is S is sine, and this is opposite over hypotenuse. This is cosine cosine, that's how we spell it, cosine, is adjacent over hypotenuse. And then we have tangent, which is opposite over adjacent. Okay, so SOHCAHTOA. So just try and memorize that. Realize what it's standing for. So, sine is opposite over adjacent. Ka is cosine of theta is adjacent over hypotenuse. And TOA is tangent of theta equal to opposite over adjacent. Another way you can kind of see this is like this, the same thing, SOHCAHTOA. It's just kind of written as those ratios. Okay? All right, so let's use SOHCAHTOA, our trig functions, in order to find some ratios. Okay? So that's what we're focusing on today, is those trig ratios. Make sure you reduce your fractions if possible, and no decimals here. All right, so first off, they want us to find the trig ratio for tangent. Well, if we look over our SOHCAHTOA, tangent uses opposite over adjacent. So we want to figure out what O over A is. So before we do that, we probably should label the sides of the triangle as HOA. So here's our reference angle. This is our hypotenuse, our opposite, and our adjacent. Again, hypotenuse is always across from the 90. Opposite is always opposite of that reference angle. And then adjacent's what's left or what's next to that reference angle. So now we know what H is. H is 20. We know that 12 is opposite and adjacent is 16. So now we can just substitute. O is 12 and A is 16. And we can simplify that fraction. So we can divide top and bottom by 4 and would get 3/4. And that would be our answer. Okay, so that's what we're trying to figure out today. That's basically it. All right, let's try another one. So this is cosine of z. So sometimes, I don't think this will be the case in the homework, but just in the future, if you ever run into this, if they say cosine z, they're saying that z is our angle. This is our reference angle. Okay, so we would label our sides. This is our hypotenuse, our opposite, and our adjacent. Okay, and then cosine, if we look up here, cosine is adjacent over hypotenuse. So A over H, and A is 21, and H is 35. We can simplify that. I think 7 goes into top and bottom. I get 3 over 5. Okay. All right, and then let's look at sine. We haven't done a sine yet, so we'll label our sides. Again, we're saying sine of A. So our reference angle is right here, which means we have our H, O, and A. Again, these kind of look like A and H look very similar, so we kind of need to look at that right angle and realize that our hypotenuse is across from it. Okay? In the past, also going back, we did talk about when we did a unit on triangles, we talked about how the largest angle is across from the largest side. And our largest angle here is 90. Okay? Nothing else can be more than 90 if we're doing a right triangle. So across from that would be our largest side. All right, well, that's kind of cool if you remember that. Anyway, so we got our sides, we labeled our sides, and now we need to figure out what does sine use. Well, sine uses O over H. So O over H, and O is 9, and H is 41. And that would be our final answer. Nothing can go into 9 and also 41. Okay? All right, just so here's some more examples. We'll go through, why don't you pause and do D, E, and F and see where we're at. All right, so labeling our sides. Here's our H, our O, and our A. Sine uses O over H, so that's our SO for SOHCAHTOA. O, OH, right? Got it? So we got 15 over 25. You can divide top and bottom by 5, would get 3/5. Okay, cosine of x. So here's our reference angle. This would be H, O, and A. Cosine, so ka, ah, AH. So we would do A, which is 10 over H, which I think is 26. It's kind of hard to see. If you did 28, that's fine too. Okay, and then we can simplify that. It looks like 2 goes in, so we can do 5 over 13. And I think that would be it. Okay, and then F. So here's our reference angle. So this would be H, O, and A. And then tangent is O over A, O over A. So TOA, or SOHCAHTOA. TOA. And we do O, which is 4, over A is 12. So that's 1/3. All right, so that is the basics. We have 3 more problems. Well, let's look at H and I. Okay, if you did this one, let's see, that would be what? If we did sine is, well, let's label it, so H, O, and A, which is sine is so, O, H. So that would be 8 square roots of 3 over 16. And then we could simplify this fraction. We really won't be running into at numbers that have roots, like the square root of 3, but just get you a little taste of what's going to come next year. But we can simplify it. 8/16 is 1/2, so it's 1 square roots of 3 over 2. Don't worry about it so much with that, okay? But you will probably run into something like H and I. So if we label our sides, well, first off, what do you maybe notice? Well, it looks like we're maybe missing some of the numbers for our sides. Okay, and that would be correct. But first, we're still going to label our sides. Here's our reference angle. This would be our H, our O, and our A. And sine is so, O over H. So we end up having O is 15 over H, but we don't know what H is. Okay, but if you recall in the past, if you're missing a side and you have 2 of the 3, then you can always use the Pythagorean theorem. Okay, and that's a squared plus b squared equals c squared. Okay, or we could use a squared plus o squared equals h squared. So what we need to make sure is that we're using the hypotenuse has to always be c. If you're using a squared plus b squared equals c squared. Okay, but our sides, when we label them, they'll probably be like adjacent, opposite, and hypotenuse. Okay, so hypotenuse has to always be what is by itself, that c squared term. Okay, so let's give this a try. We need to figure out what h is, so we will do something like a squared plus o squared equals h squared. So 10 squared plus 15 squared equals h squared. You can use your calculator to evaluate this. So let me grab mine out. I'm good with 10 squared, but sometimes I forget what 15 squared is. So 10 squared is 100 plus 15, that's 225. So if we add that together, we'd get 325 equals h squared. Okay, so 325. And then to get h by itself is we would need to square root. Okay, All right, this is not a good example here. We would end up getting a decimal, which I don't want decimals, so which means we'd just leave it as hang on one sec. I didn't mean to do that, so we'll probably need to, hopefully the next example will, yeah, I think the next one will be okay. Okay, when we take the square root of 325, it's not a perfect square, and all the problems that you'll run into will be perfect squares. So this one's probably not a good example, but we would get, I'd probably just leave it as the square root of 325. We can simplify that further, but we're not going to spend the time to take care of that. So let's look at I. I is a better example. This one, H, I won't have you a problem like that. Okay, so let's look at I. This one's a better one. So we have our reference angle, we have our hypotenuse, we have our opposite and our adjacent. Tangent is TOA, so O over A. But we're missing O. So here we'll use the Pythagorean theorem. We would do 8 squared plus O squared, or whatever variable you want to use. I feel like O is not great because it looks like a 0. So maybe here I'll just use an X. Equals H squared. So that's 17 squared. Okay. So if we use our calculator, here would get 64 plus X squared equals 17 squared, which is 289. Okay, but we need to get X by itself. So we would want to subtract 64. So 289 minus 64 gives you 225. And then we could square root both sides. So the opposite of squaring is square rooting. And we would get 15. So here we'd have O is 15. And now we could write down our ratio. So that'd be 15 over 8. And that can't be simplified. Okay? So we could have changed this. I probably changed it to something else. Maybe we can do that really quick so that we have another example. Okay. So here we've got, let's change this to be, keep it nice and easy. We'll make this be 3. We'll make this be 4. Okay. So we still have our H, O, and A. We said sine is O over H. So we need to find what H is. So we'll do A squared plus O squared, or B squared, whatever you want to call it, equals H squared. So we'd get 9 plus 16 equals H squared. That's 25. And then we would square root both sides, and we'd get H equals 5. So then we could say our O is 4 and H is 5, so that would be our answer. Okay? So sorry for the confusion there. All right, so that's it for today. If you have any questions, let me know. If you ever need to get some help, feel free to come before or after school. All right, we'll see you guys.